Good morning, fourth graders. So, sometimes you know that saying, when you have lemons, you make lemonade, and I kind of feel like this is one of those days where the internet is out at my house, and so I thought, oh, let's just get this lesson out of the way. This lesson, though, is actually really, really fun because you're going to deal with not only models, but you're also going to apply the algorithm to equivalent fractions. So I want you to just look at this really quickly. The word equal is in equivalent fractions and decimals. So what we're talking about is the fraction equivalency of a decimal and vice versa. In today's world, with computers and calculators, decimals are definitely easier to use. But when you get into studying about ratios, you're going to have to be able to go back to fractions, and your flexibility in that thinking is going to be a bonus. So you really have to be able to fluidly move between a fraction and a decimal and know what their equivalencies are. There's numerous amounts of equivalent fractions. You can have any number of equivalent fractions for a fraction, but really there's going to be one equivalent fraction for one equivalent decimal. So I drew, for some sake of some time, I drew 3 of these grids. Notice that Teaching Tool 14 will be used with today's lesson. Teaching Tool 14 is really fun. I'll go ahead and attach it there in the post. You're going to see 3 different types of boxes. They call them congruent boxes. One will be labeled a whole, and it looks like this. There will be tenths, so it's divided into tenth section. Just know that's how you say it, tenths. And then one will be divided into hundredths. So you can kind of get the idea, wrap your brain around this concept, that when we're talking about tenths and we're talking about hundredths, we're talking about small parts of something. So if I were to color in one of these bars right here, blue, I'm talking about 1/10 of this box, or one strip of this, and it would be written either as 1/10, and this fraction you should be really familiar with, or it could be written as 0.1, which is also representative of 1/10. If I came over here and I filled in one of these boxes, I know they're not exactly even, if I took one of the corners just like that, that means 1/100th of this box. So there's 100 little squares. I did count them out, so there's 10 lines going horizontal, 10 going vertical, which equals 100. So it would be represented, and this is the easy part about fractions, it looks like this as a fraction, but when you're dealing with decimals, it would look like this. So I'm asking for 1/100th of this to be represented, and that's what it looks like. When you see a whole box like this, a question might pop up like this, and you might have to use this. You can use all of these boxes, but it's just easier to use a whole box, or I would even go to hundredths because there's that ability to be flexible in your brain. This box, the 10th box, might be a little hard. So a question might say, show 3/4 on this box. How can you show 3/4? Well, that's kind of easy in this whole box because you would just divide it into 4s. Okay. So let's say this, in a class you take a poll and 3/4 of the students have a sibling. So they have a brother or sister, or more than that. And then a quarter of the class does not. So that would be represented if you were to color that in. So there's a quarter plus a quarter plus a quarter. So that's equals 3/4. So that would be how you could use one of these boxes. Skip the tenths. You could also do the same kind of thing with this hundredths grid. You could actually go divide it in half. There's a half mark. Divide it in half again. And you could see the same thing going on here. So you can color this box in, this box in, and this box in, and that truly equals 3/4. There's more ways to do this, and I'll show you how you could use a 100 box. Instead of doing this method, how you'd use 100.
And just to clarify, you can't use tenths because 10 can be evenly divided by 4 or into quarters.
Thank you. And you'd have to translate it to some unit of that it can be divisible by. So I wrote down over here, and thank you, Dawson, my lovely assistant, for reminding me of that. The power of 10 is always what you have to deal with when you're dealing with decimals. And I mean that it has to be represented by base 10. So a fraction equivalency would be 1/10, 1/100th. It goes on, 1/1000th. Now we're talking about very small pieces. This would be a 3-dimensional box with 1,000 parts. Excuse me, and you would have one of those tiny 1,000 parts filled in. So this is a very, very small number. It can keep going. It goes to 10,000, 100,000, 10,000, 10,000, whatever. it keeps going in the 10,000 realms, in the realms of 10. So I'm going to go ahead and show you kind of the example they want us to work with. So how do you take 3/4 again and translate it? So 3/4 is a fraction, but it can also be written as a decimal. And the algorithm is something that you're going to have to use today. And it's such a slick algorithm. I want you to look at 4. I've stressed this for many chapters now, that the divisor is super important. And I want you to ask this question: can the divisor be converted to a power of 10? And powers of 10 are 10, 100, 1,000, 10,000, 100,000, millionth. Those are all powers of 10. So if you were to think about this, in our algorithm, you could say, yes, I can get 4. I can't get it to 10, no matter how hard I try. I can't think of anything when I multiply it to get to 10, but I can get 4 to 100. So that's going to be the denominator I will use. What times 4 equals 100? That's easy. That's 25. And I want you to think about how many quarters there are in a dollar. That's the same concept here. So you're going to have to multiply top and bottom, top and bottom by the same number. So 3 times 25. So we're going ahead. So what are 3/4 to 75? That's right. So 75 over 100, and that's using the algorithm of multiplying both top and bottom by the same number, finding a power of 10. So 0.75 or 75 hundredths is the same amount. This can also be written as 0 because there's no ones. It's close to 1 whole, but not quite. And then, of course, 0.75. That's how you convert it. So that is I guess it's not really an irregular fraction. It's just a fraction without a base 10 that you have to find a base 10. Here's its base 10 and here's its translation. So what would that look like on a model? I showed with, again, I was able to prepare a model very quickly. So I want you to imagine that this box is divided into 100 sections. Okay. Let's say 100. So you could count up these and go 10, 20, 30, 40, 50, 60, 70, and then you can go 5. So that's one way to do 0.75 or 75 hundredths. Or you could easily, I should have had this teaching tool, but my computer let me print it off because I have no internet. You could easily just do that, like I showed you, that whole model like this, and just shade in a half and then 3/4. So 3/4. That's it. That's really what it is today. I want to show you a couple of practice examples. So if you get a fraction like this, let's say 9/12. Okay, can 12 get to 10? Can 12 get to 100? Can 12 get to 1,000? I don't know. Can you divide it? Can you multiply 12? Here's the simple thing to do. Simplify this fraction. I know that they have something in common. Right away, I'm going to divide each one by 3, and that's going to clean it up for me. That's going to find perhaps a smaller number that I can use. So 9 divided by 3, 3. 12 divided by 3, 4. There you go. You know you've seen this before. Now you can use this base number, this denominator, to multiply by a power, by a number to get it to a power of 10. And we decided that we could multiply these by 25. And the beautiful algorithm works like this. This is what you'll see your book do. So they have 3/4. After you've reduced 9/12, you get 3/4. Then you're going to see this really cool circular thing that looks like this, because you're going to come up with a new fraction, and then you're going to convert it to a new decimal. Okay. So we've decided that both top and bottom are going to be multiplied by 25. And that gives us 75 over 100. Now with our hundredths place, you now know it's going to be 0 because there's no whole number. And repeat again, 75. And it would be read 75 hundredths. Okay, let's take a few examples from our practice. Number 1, you're given 3/5. And here's what it does. There's an empty box on top. and there's a denominator below. They're going to help you out for the first get-go of it. So you'll see that this 5 is very compatible with 10. And you think, okay, what can I multiply 5 by to get it to 10? Power of 10 tells me it's going to be tenths, and I can translate it really easy. Well, that means I can multiply both top and bottom by 2. And that gives me 6/10. Okay, how is that written as a decimal? Well, 6/10 is written, let's see, I said it myself, so there's no whole number. 6/10, that means the 6 is in the tenths place. Remember, there's the tenths place, the hundredths place, the thousands, the 10,000s, the 100,000s, and it keeps going. These numbers are really small down here. But for the sake of this lesson, and for the sake of 4th grade, they only show you these two, tenths and hundredths. So that would be how you could write it as a decimal, 6/10. Let's do another one. Number 2 says 2/4. You know another name for that. They're going to give you a 50 on top and a box below. And they're going to say, okay, well, what did they do? We have to get this to that power of 10. So really, don't forget, it's multiplying by 25. Look what they did up here. 2 times 25. Yep, that gave you 50. We know that this is going to be 100. Written as a decimal, 0 point, because there's no whole number, and 50 hundredths could be written like this, or believe it or not, this is the same thing. 5/10 is the same as 50 hundredths. So again, on that box, if you were to take it and divide it by 10, it means half. Half of this box is filled in. So that could be 5/10. If you did the hundredths, where you divide this whole thing up into another 10, you still get 50 hundredths. It's just said a different way, and it looks a different way, but the value is the same. I believe the answer key wants you to save it and keep it 50 hundredths, just like it is represented here. So that's 50 hundredths said, or written in decimal form. Okay, let's take one more. So that this next stage, they're going to give you number 5. I'm just going to jump to number 5. Same things, write the fraction as a decimal. So they're not going to give you any boxes to help you with this section. So what did I tell you this time, this round? Best thing to do is to see if it can be simplified first. And that's why I've really stressed that over the last couple of chapters. You must simplify. If you can simplify it, you're going to find something that you can work with. Because right now, my brain, I can't think of anything times 8 that's going to get me to 10 or 100. But I know something will if I can simplify it. So divide by top and bottom by the same amount. Divide by 2. Okay. 2 divided by 2 is 1. 8 divided by 2 is 4. Ah, there's that 4 again. All you have to do now is multiply that 4 by something to get it to a base 100, or a base 10. And in this case, it's going to be 25. So when we multiply top and bottom by 25, we get 25 over 100. And that, written as a decimal, let's clean that up, would be 0, because there's still not a whole yet, 0.25. That's it. And it would be read 25 hundredths. Get a whirl today. This is a really fun lesson. I think you'll like the algorithm. And now your understanding is really strong. Thanks, bye.